Example 3. The line y is equals to 2x plus 10 is a chord of the parabola x equals to 4t, y is equals to 2t squared. By putting the line in the form y is equals to half p plus qx minus apq, we want to find the values of p plus q and p times q, and hence find the coordinates of the endpoints of the chord. So if we take a look at this, right, let's get some space. So while dealing with the parabola, x equals to 4t and y is equals to 2t squared, so when we look at the parametric equations of this parabola, the first thing that we should take note of is normally my parametric equations are given by x equals to 2at and y is equals to at squared. So in this particular case, we're now dealing with a parabola where the focal length is equals to 2, right? That's the first thing that we need to recognize. Now, generically speaking, the equation of a chord is given by y is equals to half p plus q times x minus apq. So obviously in this particular case, if a is equals to 2, then our chord is simply given by half p plus qx minus 2 times p times q. Now the whole idea of the chord is that p and q are supposed to be parameters, right, that tell us where the point p and where the point q actually are. So for example, the point p is going to be given by 4 small p, comma, 2p squared, and the point q is supposed to be 4q, comma, 2q squared. So if we know the values of p and q, then we actually know where these 2 points actually lie. So knowing a fixed value of the parameter is the same as knowing the coordinates of that particular point. So in this case, if I say that y is equals to 2x plus 10, right? So if y is equals to 2x plus 10 is a chord, then what that means is that by comparing the equation y is equals to 2x plus 10, right, with that of the generic equation of the chord, then we can say that half lots of p plus q is equals to 2, and we know that negative 2pq is equals to 10, right? And of course from this we know that p plus q must therefore be equals to 4, and p times q is equals to negative 5, right? And these 2 equations, let's call this equation 1, let's call this equation 2. Solving equation 1 and equation 2 allows us to find the values of the parameter p and the parameter q. The moment we know what p and q actually are, right, then we know where our endpoints of the chord are. And now if we start by taking equation 1, right, and rearranging it so that q is equals to 4 minus p, then we can take this and substitute this into equation 2. So if we sub into equation 2, then naturally we're looking at p times q. Q is now equals to 4 minus p is equals to negative 5. And of course, if I expand, right, we're going to be looking at 4p minus p squared is equals to negative 5. And rearranging is going to give us 4p squared minus 4p minus 5 is equals to 0. And of course, this quadratic equation is very easy to solve. I mean, first it factorizes into p minus 5 times p plus 1 is equals to 0. And this tells us that p is either equals to 5 or p is equals to negative 1, right? Of course, we know that q is equals to 4 minus p. So therefore, if p is equals to 5, then q is equals to negative 1. Alternatively, if p is equals to negative 1, then q is equals to 5. Now, when we're considering these 2 sets of answers, right, you guys can see that the values are exactly the same, except they're reversed. Now, the reason why they're reversed, right, doesn't mean that we've got 2 different sets of answers, but instead, given the context, right, of what we're looking at, very roughly speaking, let's say we've got the parabola, okay, that looks like this, and I'm coming along, I'm telling you guys that y is equals to 2x plus 10 is a chord. So if y is equals to 2x plus 10 is a chord, it looks like this, and you guys can see that the chord has 2 endpoints, okay? And the problem here is we don't know which point to call p and which point to call q. If p is at this point here, then of course the parameter associated with this point is going to be p is equals to negative 1. And if q is over here, then the parameter associated with q is going to be q is equals to 5. Okay, so this point is going to be associated with q is equals to 5, and this point is going to be associated with p is equals to -1. Now, alternatively, if we want to swap them, okay, because no one said that the first point that comes up on the left has to be p, and the second point has to be q, right? So if q turns out to be the first point on the left, and p turns out to be the second point on the right, then of course, the values are going to be reversed. Then we'll be dealing with q equals to -1. So if I use another color, so if q is this point, right, then q is equals to -1. Okay, and if p is this point, then p is equals to 5. And that's essentially how it reverses, right? But it doesn't really change what the actual endpoints of the chord actually are. Okay, and they're reversible in the sense that we can essentially call one of them p, one of them q, and can reverse what I call them. Okay, that accounts for why there are two different sets of answers and why they are essentially the opposite of each other. Okay, so therefore to finish the question, because what we actually want to do over here is we actually want to find the coordinates of the endpoints. So the coordinates of the endpoints, okay, coordinates of the endpoints are therefore going to be, now remember your parametric equations are given by x equals to 4t and y is equal to 2t squared. Okay, so if my first parameter is going to be 5, remember we call the 2 points p given by 4p comma 2p squared, and q is given by 4q comma 2q squared. So naturally, if I go with the first set, okay, so this is actually going to go with my pink labeling, right? So p, if p is equals to 5, as in the parameter p is equals to 5, then we're looking at 4 times 5, so that's going to be 20, comma 2 times 5 squared, so that's going to be 20, comma 50. And my second endpoint, right, given by q equals to -1 is going to be -4, comma, +2, right? That's just taking q equals to -1 and substituting that into 4q, comma, 2q squared. Okay, so that's what we have for the coordinates of the endpoints. Now, moving on to part 2, right, we want to show by using a similar method that y is equals to 2x minus 8 is a tangent to this parabola. So if I want to check out y is equals to 2x minus 8, right, let's set everything up as we would expect. So in this case, where a is equals to 2, the generic equation of our chord is given by y is equals to half p plus q times x minus 2 times p times q. And here I'm given an equation which is y is equals to 2x minus 8. So if I take y is equals to 2x minus 8, okay, and we assume that it's a chord, then to find the values of p and q corresponding to the endpoints of my chord, okay, so if I've got x, I've got y, I've got my origin, and I've got my parabola, okay, very shoddy parabola. So if I've got a chord, okay, then I know that it's got two endpoints. One of them is going to be given by the value of small p, and the other one is going to be defined by the value of small q, okay, the parameters. Okay, I've been saying that once we know a fixed value for the parameters, we've pretty much got the coordinates for the 2 points. Okay, so the first point p is going to be given by 2ap comma ap squared, right, defined by the value of small p. Okay, in this case, I know that a is equals to 2, but for my second one over here, right, q is going to be given by 2aq comma aq squared. So when the question tells us to show by using a similar method, I'm going to equate these two in an attempt to find the values of small p and small q, which define the endpoints of my chord. So from this, we can see that half p plus q is equals to 2, and 2pq is equals to 8, right? They both got the minus sign in front of them, so that's not going to be a problem. So this tells us that p plus q is equals to 4, and p times q is equals to 4. So usually when we think about these two, right, the sum of the two numbers equals to 4 and the product of the two numbers equals to 4. What this actually means, right, is that p and q equals to 2 works, right? 2 plus 2 is equals to 4, and 2 plus 2 is also equals to 4. But if I want to be more rigorous in my proof, let's say that this is equation 1, let's say this is equation 2, and let's solve these two algebraically. So if I start off with equation 1, right, if I say that q is equals to 4 minus p, right, and say I take this and I substitute this into equation 2, then what we're looking at is p times 4 minus p is equals to 4. If I expand the lot, we're looking at 4p minus p squared is equals to 4, meaning that p squared minus 4p plus 4 is equals to 0. And this is very easy to solve because we know that this is just a perfect square given by p minus 2 all squared is equal to 0. Right? So in other words, p is equals to 2 is the only solution for p that we have. And naturally, if p is equals to 2, that means that the corresponding value of q is also equals to 2. So when we have p and q, like I said earlier, p and q, the parameter small p and the parameter small q, they define where our endpoints of the chord actually are. So when they are actually the same point, it means that my line does not cut through the parabola so that p and q are distinct. When the value of small p and small q are the same, then that means that my endpoint is actually exactly the same point. And in this case, what we're actually looking at is we're actually looking at the equation of a tangent, okay? Because chord always has two distinct points, okay, as its endpoints, whereas the tangent doesn't, okay? So since in this case, the points of contact, okay, point of contact, okay, is repeated, right? Then this shows, okay, this shows that the line is not a chord, okay, because it doesn't intersect my parabola at 2 points. So rather, the line is a tangent, right? So that's all we have for part 2. And now lastly, for part 3, the question wants us to now similarly show that y is equal to 2x minus 10 does not meet the parabola. So by exactly the same principle, okay, I'm going to take y is equal to 2x minus 10 and I'm going to compare it with the standard equation of the chord. And I want to find the values of p and q, okay, that represents the endpoints where my line intersects with my parabola. So in this particular case, I know that the chord that we're dealing with is given by y is equals to half p plus q times x minus 2pq. And with this, right, let's say that we've got the line y is equals to 2x minus 10, right? So if I want to solve for the values of p and q, right, I'll equate just like what I did for the previous two parts. So say I've got half p plus q is equals to 2. And I've got 2pq is equals to 10, right? Such that p plus q is equals to 4 and p times q is equals to 5. So let's call this equation 1, let's call this equation 2. And what I want to do is I want to solve for the values of p and q, which tells me where my line intersects with a parabola, okay? Assuming that this line is actually a chord. So if I take equation 1, rearrange it so that I'm looking at q is equals to 4 minus p, and I substitute this into equation 2, then I'm looking at p times 4 minus p is equals to 5. So if I expand this, right, I've got 4p minus p squared is equals to 5. Or in other words, I've got p squared minus 4p plus 5 is equals to 0. Now, when I try to solve this equation, right, one thing to take note of is I can't actually factorize it, okay? Secondly, if I try to use the quadratic formula, I'm going to get b squared minus 4ac, right? B squared minus 4ac is going to be minus 4 squared minus 4 times 1 times 5. 16 minus 20 is actually smaller than 0. So if b squared minus 4ac, which is the discriminant, is smaller than 0, then that means that the quadratic formula fails because this equation has no real roots. Okay, so therefore there are no real solutions, okay, for p. And as a result, if there are no real solutions for p, there are going to be no real solutions for q as well. So given this particular scenario, what this actually means, right, is that if I've got a parabola, okay, if I've got a parabola and I'm saying, okay, let's take this line, right? Normally, if my line intersects my parabola at 2 points, then I'm going to get two values for p and q, okay? If p and q turns out to be the same point, then I've got a tangent. And in this case, when there's no solutions for p and q, that means that we've got a line that does not intersect with a parabola, okay? No value for p means that we cannot find a point on the parabola such that it meets the chord, or it serves as the endpoint for this chord. Okay, so therefore, that shows that line does not meet, okay, the parabola. So that's what we have for part 3, and this concludes example 3.